Hello students, welcome back to the video lecture series of numerical methods in chemical engineering. We have started the last unit of the syllabus, numerical solution of the ordinary differential equation, and we have started the step-by-step methods. Why these methods are known as step-by-step methods? Okay, first of all, I would like to tell you that in this chapter we will study only the solution of the first order differential equation. So only y dash term will be coming in that. Okay, and one more thing, to solve the d square y by dx for the higher order differential equations, we are not using the numerical solutions. Okay, now step by step method. Why the Taylor series and Euler series and Runge-Kut methods are known as step by step? Because if you want to find y1, if you want to find the solution of y1, then for that the previous value of y is required. So except y0 you cannot find y1. Similarly, the value of y2 depends on y1, value of y3 depends on y2. Okay, so directly you cannot find the value of y3. So for finding the value of y3, you have to compulsory find the value of y1 and y2 first, and then you can find the value of y3. So these methods are known as step by step. We have already completed the Taylor series method. Okay, you have to remember the formula and then you have to use that formula to find the solution. Okay, today we will start a new method, that is Euler's method. Fine. In Euler's method also, what will be given? See, first of all, like other methods, given that dy by dx is equal to function of x comma y. Okay, dy by dx is equal to function of x comma y, and this is also IVP. So y of x0 is equal to y0 will be given. Okay, see, let us draw this, understand this graphically. This is our x-axis, y-axis. Here will be my x0. Okay, and y0 is also given. Here is my y0, and here I can write my point x0 comma y0. Okay, fine. So okay, here I am taking x1 and the step size is h. Okay, see, from this point we have to draw a tangent. We have to draw a tangent. Okay, so the slope of the tangent will be dy by dx. So we can say the slope of the tangent is f of x comma y. But at point x0 y0, the slope of the tangent can be written as f of x0 y0. Okay, now let us consider the point at which I am getting the intersecting point. The point can be written as x1 y1. So I am getting a value of y. Okay, a value of y is obtained with the help of the Euler's method. So I am naming that value of y as y1. Okay, so if I want to write the formula for the slope, so I can write f of x0 y0 is equal to y1 minus y0 upon x1 minus x0. See, once again I am repeating, x0 y0 is the given point. We have to draw a tangent and the slope of the tangent is already given f of xy. But at point x0 y0 we can write the slope like this, f of x0 y0, and we are getting one point. Okay, but our actual point is here. This is our value of y1, and this is the value of y1 that we are getting with the help of Euler's method. So we can say there is error in the Euler's method. The actual value of y1 is this, but we are getting the value of y1 here. Okay, so there is some error in the value of y1 or y2 and y3 and so on. Okay, fine. So let us first of all derive the formula for the Euler's method. Okay, now y1 minus y0 can be written as x1 minus x0 into f of x0 y0. Okay, so y1 minus y0. What is our x1 minus x0? See, x1 minus x0 is h. So I can write here h. H is our step size into f of x0 y0. So what will be my y1? See, y1 according to our Euler's method will be y0 plus h into f of x0 y0. Okay, see, I am drawing it again so that it will be clear to you. Okay, this is the formula to find y1 with the help of Euler's method. Let us study that graphically. Here x-axis, y-axis, here x0, y0. Okay, this is our y0, this is our x0. So our point will be x0, y0. Okay, here is my x1, this is my h. Okay, and I have to draw a tangent. So my value of y1 will be here. But the actual value of y1 as per the curve is here. So there is a difference in this value. This is the value obtained from Euler's method and this is the value from the curve. So there is some error. Okay, so to remove the error we will use the different method, that is modified Euler method, but this is the formula to find y1. Now how we can find the value of y2? How we can find value of y2? See, for y2 we are having two values, x1 and y1. So one point is there, x1 comma y1. Okay, this is our point, and from this point, see, for your simplification I am just showing the point x1 y1. See, x1 y1 will be here. Again we have to draw the tangent and we will find the value of y2. Okay, but again there will be difference in the value of y2 that is obtained with the help of Euler's method and the actual value that is obtained at the curve. Okay, how we can find y2? Y2 can be found by y2 is equal to y1 plus h into f of x1 comma y1. Okay, similarly y3 can be found by y2 plus h into f of x2 comma y2 and so on. So if you want to find yn plus 1, okay, so if you want to find yn plus 1, then yn plus 1 can be found by yn plus h into f of xn comma yn. This is the general formula to derive or to solve the numericals of Euler's method, okay, in which it is compulsory to find the previous value of y to find the next value of x. For example, next value of y. If I want to find y2, then y1 is required. If I want to find y3, then y2 is required. That's why this method is known as step-by-step method. Fine. Let us solve one numerical on the basis of this. See what is given. Let us consider one numerical. Find y of 0.4 for dy by dx is equal to y minus 2x by y, and the initial values are given y of 0 equals to 1, and we have to take h is equal to 0.1. Okay, see, if you want to find the value of y of 0.4, okay, first of all we have to write that for how many steps we have to solve the numerical. See, f of x comma y is given. F of x comma y is y minus 2x by y. The value of x0 is given. The x0 is equal to 0 and y0 is 1. Here the value of h is to be kept as 0.1. So what is our x1? X1 will be 0.1. So we have to find y1. X2 will be 0.2. So we have to find y2 also. x3 is equal to 0.3, so we have to find y3. Okay, and x4 is equal to 0.4, so my y4 also I have to find. So in this way we have to find up to y4. Okay, on the basis of this you can check that up to which step we have to calculate. Okay, so if I will find y1, then y1 will be y of 0.1, y2 will be y of 0.2, y3 will be y of 0.3, and y4 will be y of 0.4. So we have to find till 0.4. Okay, so after this we have to make a table. Again we have to make a table. So this will be very easy for you. In the table we have to write the approximation number. Okay, the value of xn, yn, h into f of xn yn, and here will be yn plus 1. Our answer will be here. Okay, what is our first value? The value of xn and yn. So you have to start from 0. So xn is 0, yn is 1. F of xn comma yn. How we can find this? So we have to place both these values in y minus 2x by y. So my answer will be, okay, f of x and yn, and then we have to multiply it by 0.1. F of x and yn, so 1 minus 0, that will be 1. 1 into 0.1 is 0.1, so 0.1. Then yn plus 1, we have to add these two values because yn plus 1 is what? Yn plus h into f of xn comma yn. Okay, so my answer will be 1.1. Okay, now what is our next value of x? 0.1, because we have to add h in this, so 0.1 and yn. Now our yn plus 1 will be our yn for the next iteration. So my yn will be, yn plus 1 is transferred into yn for the next iteration. Then again I have to find the value. Okay, my answer will be 0.0918, and by adding both of these I will get 1.1918. You have to solve it by yourself. Okay, third value will be 0.2, fourth and fifth 0.3 and 0.4. Okay, for 0.2 the yn will be 1.1918. Then I have to find h into f of x and yn. The answer will be 0.0856. By adding both of these you will get 1.2774. Okay, for 0.3 1.2774 will be our yn. Then here you can find 0.0808. Then you have to add these two values. My answer will be 1.3582. Okay, see here, remember that this value, okay, this value is yn plus 1. So if I am placing here, this value is y of 0.3. Okay, this value I have to write here 1.3582. So for xn is equal to 0.4, I have got the value. So there is no need to find these two values because this value is to be written here. That means what? For xn is equal to 0.4, this is our yn, and what we have to find? We have to find y of 0.4. So this is our y of 0.4. Actually we have got the answer here, but for our simplicity, for our understanding, better understanding, we have to write this value here. So 1.3582 is the answer for y of 0.4. Okay, so in this way you can solve the numericals of Euler's method. In the next lecture we will study about modified Euler's method. Till then, have a good day. Bye bye.